The topic of this video is integration. Actually, it is definite integration. We are going to use integration to be able to find the area under a curve. Now we know that if integration of f of x is capital F of x plus c, then definite integral is, we have limits for the integration from a to b, where a is always less than b. And how do we calculate it? After finding the integration, the capital F of x, first of all we are going to substitute b, then substitute a, and find the value. Example, find the value of integration from 1 to 3, 6x cubed minus 4 dx. The answer is going to be, what is the, make it squared? The integration is going to be 6x cubed over 3 minus 4x is the integration from 1 to 3. Here the simplified form of that one is 2x cubed minus 4x from 1 to 3. It is equal to, first of all we have to substitute 3 there. Or let's carry on from there. From 1 to 3, which means first of all substitute 3, then substitute 1 there in the integration. 54 minus 12 minus 2 minus 4, so 42 plus 2, the answer is 44. Now this is the definition of definite integral, and we have a simple example here. Today's main topic is area under curve. Say that we have the function f of x here and its graph, and we want to find the area from a to b under the curve y is equal to f of x. This area is equal to the definite integral from a to b of the function f of x. Let's do an example for this one. Find the finite area, means it has solid boundaries. We know the boundaries. It's not an open area. That's the meaning of finite. Find finite area bounded by curve f of x is equal to 4 minus x squared and x-axis. So first of all, let's have a quick sketch. If the function f of x is equal to 4x squared, we know that it is n-shaped. 4 minus x squared is equal to 0, x squared is equal to 4, x is equal to minus 2, and x is equal to 2. This is the graph of from minus 2 to 2, and that's the area here that we are going to find. So by using the integration 4 minus x squared dx, 4x minus x cubed over 3 from minus 2 to 2. First of all, we have to substitute 2 there. 4 times 2 minus 2 cubed over 3 minus 4 times minus 2 minus minus 2 cubed over 3. So it is 8 minus 16 over, 8 over 3 minus 8 plus 8 over 3. So the answer is 16 minus 16 over 3, 32 over 3 unit squared is the answer. This is the first word that I am going to use to describe definite integer to you. Now let's have a quick picture and carry on. Let's clean the board. Now, what happens if the graph is under x-axis? Let's have an example about that situation and see what are we going to do. If the graph is, if we have such a graph and if the area is under x-axis, that means from A to B, if the y is equal to f of x, from A to B, f of x dx will be a negative number. But after finding a negative number, you are going to give its magnitude and say that if this is A, you are going to say that area of curve is A, not negative A. You cannot have a negative A. You cannot have a negative area. Now, let's have an example for that one. Say that find the finite area bounded by f of x is equal to x squared minus x minus 12. So if f of x is equal to x squared minus x minus 12, x minus 4, x plus 3 is equal to 0, x is equal to 4, x is equal to minus 3, and this is a quick sketch of the curve f of x is equal to x squared minus x minus 12. This is the quadratic graph for the given function, and this is the finite area. So we are going to use integration to find this finite area from minus 3 to 4 x squared minus x minus 12 dx will give the area. It will be from the integration part will be x cubed over 3 minus x squared over 2 and minus 12x. This is the integration. That expression here is the integration of x squared minus x minus 12 from minus 3 to 4. First of all, we need to substitute 4. 4 cubed over 3 minus 4 squared over 2 minus 12 times 4. Now we have to substitute minus 3 to the integration. Minus 3 cubed over 3 minus 3 squared over 2 minus 12 times minus 3. Let's have a quick calculation here. 64 over 3 minus 16 over 2 minus 48 minus 9 minus 9 over 2 plus 36. Here 64 over 3 minus 56 minus 9 over 2 plus 27. And the answer is going to be, where's the calculator? Here's the calculator. Let's find the value. And the answer is minus 343 over 6. And you have to say that, of course, we were sure that it is going to be a negative number because the area here is beneath, under the x-axis. So it has to be negative. But we have to mention that area is 343 over 6. You cannot have a negative area. You have to remember that. You need, yes, the answer you may have a negative answer here, but you have to mention that the area is always positive. Always positive. Now another picture from Messenger. Now let's have a cubic graph and its area, finite area. Example. Find the finite area bounded by curve y is equal to x cubed minus x squared minus 6x and the x-axis. First of all, we need to have a quick sketch of this curve. Y is equal to x cubed minus x minus 6x. And we know that this is a cubic curve and has a shape similar to that one. Now let's find the x-intercepts. After a quick simple factorization, we know that that is equal to that expression here. Let's have a quadratic factorization as well. Now we can find the x-intercepts very easily. X is equal to 0, x is equal to 3, x is equal to minus 2. So the graph is going to be in that shape. This is minus 2 and this is 3. Now we have to be very careful because we have two different areas here. We have one there, the finite one, and another one there. Let's call this one A1, this is going to be A2, and we have to calculate them separately. A1 is from minus 2 to 0, x cubed minus x squared 6x integrated. So x to the power of 4 divided by 4, x cubed over 3 minus x squared over 2 from minus 2 to 0. First of all, we have to substitute 0 there, and when we substitute 0 there, it becomes 0, because 0 multiplied anything is 0. Minus, let's substitute minus 2 there, minus 2 to the power of 4 divided by 4, minus 2 cubed divided by 3, minus 6 times minus 2 squared divided by 2. So 0 minus 4 plus 8 over 3 minus 12. The answer is minus 8 over 3 minus 8. That is 16 over 3 is the area A1 from minus 2 to 0. Now we have to calculate area A2. Remember, area A2, the integral is going to be negative because the area here is under the x-axis, but we have to take the magnitude of it. We have to take the positive answer. From 0 to 3, x cubed minus x squared minus 6x, it is from 0 to 3, A2. Let's call it A2 dx. Add to the power, divide by that number, add 1 to the power, divide by that number, add 1 to the power, divide by that number, from 3 to 0 to 3. So 3 to the power of 4 divided by 4 minus 3 cubed divided by 3 minus 6 times 3 squared divided by 2. Let's substitute 0 there, and then the expression is going to be 0 when we substitute 0. So 81 over 4 minus 9 minus 27 minus 0. So 81 over 4 minus 36, and the answer is minus 63 over 4. So this is the value for A2 is going to be 63 over 4. We know that, we already knew that the answer is going to be a negative one, because we cannot have a negative area, we have to take its magnitude. That's the case. All So let's find the total area. A1 plus A2 is equal to 16 over 3 plus 63 over 4. The answer is going to be 253 over 12. We have to write unit square there because it's an area. It has to have a square unit. Yes, that's an example of a graph which has positive integration, also a negative integrated value. Now again a picture of the board and continue. Now the next topic is area between two curves. Now the next topic is area between two curves. Area between two curves. If this is y is equal to f of x, the function f of x, and this is the graph for y is equal to g of x, and if you want to find the area from A to B between curves f of x and g of x, area will be defined as from A to B, the top one minus the bottom one, take the integration, substitute the values and get the area. Remember, always for the boundary, for the finite boundary, we have to take the top one minus the bottom one. Always, that's the case. Let's have two examples about this one. Example. Let's have a graph. Say that this is y is equal to x squared minus x plus eight. Yes. And we have a straight line here. Y is equal to x plus 3. This is 3, this is 8, this is A, that is B. First part of the question, find the coordinates of points x squared minus 5x plus 8 must be equal to x plus 3. X squared minus 6x plus 5 is equal to 0. X minus 1, x minus 5 is equal to 0. So x is equal to 1, x is equal to 5. Here I took x to the left hand side, made this 1 minus 6, take 3 there, 8 minus 3 becomes 5, and these are the x values. So, part B, find the finite area bounded by y is equal to x squared minus 5x plus 8 and y is equal to x plus 3. When you check the graph, it is easy to see that we are looking for the area of this shaded part. Now, when you check the shaded part here, which equation is on top? It is very easy to see that this straight line with the equation y is equal to x plus 3 is on the top. And that quadratic curve is at the bottom. And remember the rule, we have to find, and this is 1, that is 5. From the area of the bound of the finite region here is going to be from 1 to 5, top one minus the bottom one, which defines the shaded region here. Top one minus the bottom one. X plus 3 minus x squared minus 5x plus 8. Always top graph, top equation minus the bottom equation. That's the case. Now let's have some algebra here. X plus 3 minus x squared plus 5x minus 8 dx. A further simplification. X minus x squared plus 6x minus 5 dx. Do the integration, minus x cubed over 3 plus 6x squared over 2 minus 5x from 1 to 5. First thing to do is to substitute 5. Minus 5 cubed over 3 plus 6 over 2 is 3, 5 squared minus 5 times 5. Then we have to substitute 1 there. Minus 1 cubed over 3 plus 6 over 2 is 3, 1 squared minus 5 times 1. Do the calculation. Minus 125 over 3 plus 75 minus 25 minus 1 over 3 plus 3 minus 5. So, minus 125 over 3 plus 50 plus 1 over 3 plus 2. Minus 124 over 3 plus 52. So the answer is minus 124 plus 156 over 3. The answer is 32 over 3. Of course, unit squared. Yes. Do you have any questions? If you have any questions, write from Messenger. If you don't have any questions, I am going to the picture of the board and continue. Yes, no questions. Let's have another example about area between two curves, and by giving the numerical method trapezium rule we will finish the chapter. Actually we are going to finish P2 today. Yes, another example. This is the graph for y is equal to x cubed. This is y is equal to x cubed, and this is y is equal to x squared. And the question is, find the finite area bounded by y is equal to x squared and y is equal to x cubed. First of all, we need to find the coordinates of that point and that one, and very easy to find. X cubed minus x squared is common, x minus 1 in the brackets, equate to 0. Either x is equal to 0 and x is equal to 1. So this is, that point is the origin, that is 0, and that point is 1. And this is the finite area. To be able to find that finite area, we have to find the top equation and the bottom equation. For that finite area, for that finite shaded region, as you see, this is the top graph, which is the graph of the equation y is equal to x squared. So the top equation from 0 to 1 for the shaded region is x squared. When you check the graph, the top equation is y is equal to x squared. The bottom equation is x cubed for the shaded region. Again, for the shaded region, for the finite area bounded by x squared and x cubed, we have to find the top equation and the bottom equation. When you check the graphs, the top equation from 0 to 1 is the equation of the y is equal to x squared, and the bottom one is the equation for y is equal to x cubed. And always top minus the bottom. And do the integration, x cubed over 3 minus x to the power over 4 from 0 to 1. Substitute 1 there. 1 cubed over 3 minus 1 to the power of 4 over 4 minus, we have to substitute 0 there, and anything involving 0 is 0. So 1 over 3 minus 1 over 4 minus 0, 1 over 12 units squared is the answer. Do you have any questions? Checking my messenger. No questions, so another picture from the board. and carry on. Today's last topic is numerical methods, integration by numerical methods. Trapezium rule. Numerical methods, trapezium rule to find area under a curve. If you remember, area is equal to from A to B f of x dx. Say that this is the function y is equal to f of x. That's x is equal to a. That one is equal to b. And we have to divide that area to finite stripes. Each one is called a stripe, and we have n stripes here. So b, from A to B, the length is divided into n, and these are the y values: y0, y1, y2, and that one is yn. And we need to have a table here to calculate x0, y0, x1 corresponding y1 till we reach xn, yn, and we have a constant h there, which can be calculated by b minus a over number of stripes, or x1 minus x0 also gives the value for h. And the formula which defines the area from A to B f of x dx is equal to, by using the areas of the trapeziums there, 1 over 2 h, which can be easily calculated, y0 plus 2 times the y values between the first one and the last one, plus the last one will give you the area. Let's have a quick example about this one. Example. This is the curve for y is equal to 2 to the power of x. From 1 to 3, by completing the following table, find the area under curve y is equal to 2 to the power of x from x is equal to 1 to x is equal to 3. Let's have the table x, y, 1, 1.5, 2, 2.5, and 3. So, this is the question. Now, solution. What is the area by trapezium rule? It is 1 over 2 h y0 that is y0, that is y1, that is y2, that is y3, and that is y4. y1 plus y2, y3, and the last one has to be outside of that brackets. You have to remember that. And that is the rule. And we know the function. The function is 2 to the power of x given in the question, and we know the x values, so it is very easy to calculate the corresponding y values. And can we calculate h? Yes, very easy. How? That one, the second x minus the first one always gives you the value for h, and so h is going to be 0.5. 1 point minus 1 gives you the h. Now let's calculate the corresponding y values for each x. This is 2 to the power of 1 is 2. 2 to the power of 1.5 is going to be 2.83. This is 4. That one is 5.66, and that one is 8. So substitute in the formula. We already know the value for h. It is 0.5. What is y0? 2. What is y1? 2.83. What is y2? 4. What is y3? 5.66. Substitute y4 there, 8. And after doing the calculation, the answer is going to be and the answer is 8.75 unit square. That's it. End of areas under a curve. Do you have any questions? Yes, if you don't have any questions, see you tomorrow at 1 o'clock, and I am going to solve for tomorrow. I want you to try to solve the exam practice at the back of your P2 book. Please try to solve the exam practice at the end of your P2 book. I am going to solve it tomorrow. See you. Bye.